Welcome everyone. Thank you for joining us for today's web demo. Topic is an overview of Salford Predictive Modeler, SPM for non-manufacturing. SPM is one of the product by Minitab. I'm Nausunawati and currently I'm technical support specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia and Singapore. So our topic today is an overview of Salford Predictive Modeler, SPM, for non-manufacturing. Before we get started, this session is webcast, so maybe we have audio delay. If you cannot hear clearly by speaker, you will be able to dial toll-free number for Malaysia 1800-807-043, for Singapore 8001-011-441. If you have any question during presentation, please type them into the question box in your control panel. You may send any time during presentation, but I will address them during Q&A session at the end of this session. I will turn on the listen only mode once we get started to avoid other sounds for recording. For your information, this web demo will be recorded and you will access back at our website www.visits.com. So our agenda today is we starting with the predictive modeling, and then one of the technique in predictive modeling is machine learning technique, and then our product by Minitab for machine learning is Salford Predictive Modeler, and then we use one of the analysis engine or model in Salford Predictive Modeler is classification and regression tree. Okay, predictive modeling is the analysis of set of data to identify meaningful relationships and to use of this relationship to better predict outcome and make better, faster and actionable decisions. Predictive is use historical information to describe past relationships from which to draw insight about the future. This insight can apply to several aspects of a business, such as customer, or provider, and distributor behavior. Predictive modeling is not new, but why predictive modeler is quite popular? Because nowadays we have a lot of competitive pressure. We have a lot of competition in the same product, and then we go for the revolution of big data. So as we know nowadays, the generate of our data is about 2.5 quarter million bytes of the day, and then we have ability of new data like social media data. We have image data, we have a sensor, we have audio data, and then after that our computer power with the high speed processing our data and capture our data, and then also we have a new technology to store and manage our data. So that's why we need have new technique, we call it machine learning, to solving this problem. Okay, so we go for the what is the machine learning. Machine learning is a modern statistic plus with the computer sciences. Basic one, machine learning is a method to learn information directly from the data without relying any assumptions, to make the predictions and decisions. Basically, machine learning to solve the problem of like we have a large amount of data, we have a lot of variables, we have a complex interaction, we have a lot of non-linear relationship between each predictor, and then we have a lot of missing value, and then we have a lot of extreme outliers existing. So basically, machine learning is often able to do this automatically. Okay, machine learning technique, we have two. The first one is we call it unsupervised, and then second one is supervised. Unsupervised means that you don't have any target existing, and you just want to find the grouping in your data. So basic method in supervised is we call it clustering. Okay, so for example, you can using k-mean clustering, hierarchical clustering, or principal component analysis. And then for the supervised, you have your target, which is your Y, and then you have a multiple predictor, your X. So basic one, for the supervised, we have two classification. We have the first one is classification, and then second one is a regression. Classification means that your Y, your target value is a categorical or binary or multi-classification. Let's say binary is 1, 0, yes, no, or multiple classification, like you have a label in your scale, let's say low, medium, high. So that one is, we consider that as a classification. So let's say your target or your Y is the numeric, so they consider that is a regression. So both of the classification in supervised, you can using our model, like CAT is a classification and regression tree, is a decision based, and then we have a advanced model like random forest, and we have a tree net, and then we have a MARS is a multiple adaptive regression spine, most for the non-linear regression, and then we have also regression, and you can go for the logistic regression. Okay, so for our limited product, we have a exclusive product. We call it Salford Predictive Modeler, or SPM. Okay, Salford Predictive Modeler is a powerful machine learning software fit for the developing predictive, descriptive, and analytic models. Actually, Salford already in market older than Limited, because Limited quite new to acquire the Salford in March 2017, almost 3 years. Okay, so basic one, Salford Predictive Modeler have original author or original algorithm from the original author for this kind of the analysis. Let's say for the classification and regression models, we have a tree net boosting, we have random forest, we have automate nonlinear regression for the mark. So basically, all these algorithms is from original author. Let's say for the cat, we have the from the John Brightman and then Leo Brightman. Also same with for the random forest is from the Leo Brightman. So all the algorithms inside the SPM is from the original author. This one is our strength for this product. And then for today's session, we go for the classification and regression tree. Okay, so this one is how SPM works. Basically, SPM can import our data to the SPM, and then you can go for the summary statistics. Let's say this is statistic, you can go for the graph, and then you can go for the correlation to find out relationship between each predictor and the predictor with our target. And then after you know about the relationship between each predictor and then predictor and the target, you can go for the build our model. We call it predictive analytic model. And then this function, we have exclusive model. Let's say the CAT, TrueNet, Random Forest, Mars, Urinal, ISO, and GPS model. after you get the best model from this software, so you can deploy your model to do the score. Score means that you can do the prediction, and or you can translate the this model to transform to other language. Okay, so this one is how SPM works. So I go directly to the SPM. Okay, so once you launch the SPM, okay, so you can get this kind of the interface. Okay, here is, we call it the menu button. Okay, so the same, we have file here, we have edit, we have a view here, we have explore, we have model, report, window, then help us, the help one. Okay, once you launch your SPM, so you get the classic output. Okay, but in SPM we doesn't have a worksheet like Minitab statistical software. You need to import your data from the other file into SPM. Okay, so how? You go for the file and then open data file. So this one is the style of the file where SPM can import. Let's say you have from the Excel file, from the Minitab itself, so you can calling your data directly to in this software. We call it SPM. Okay, so we go back to this one. Okay. Okay, so for this one, we have example here. Problem is a multinational finance services firm has data on the 664 borrowers. 461 of them are not default status, and then 203 are default status. For this example, actually, our objective is we want to predicting which potential customer are likely to default on their loan. So our predictor or our variables is age, and then we have education, and then we have a number of family members, we have a credit bureau measurement, we have number of credit cards, and then we have a number of patient listed, and then we have a home owner status, we have a time or year work experience, and then our target or our one is 0 is for no default, and 1 is a default. And then also we have a credit limit, it means that loan amount. Gender is a male and female. We have also income variables, and we have marital, and then we have PIN postal code. Okay, so basically this case is we consider that classification cases because our target is to classify. 0 is no default, 1 is a default. Okay, so we go for this data set. So you need to find where you save it. For my cases, I save it in desktop. Okay, good bad data set. Okay, I will be using good bad data set. So we open. So I will do how to open. Go for the file, open data file. Okay, for this case, desktop, and then go for the good bad, and then click open. So you get this, we call it activity window. Once your output, your data already in SPM, so they pop out the activity window. In this activity window, they provide the information like how many records you have, how many variables you have, what type of variables you have, whether it's character or numeric. Character means your text data. or classification data. And then here is a variable name in your data set. And then activity yang you can do it in this SPM is it you can view your data first if you're not sure that one is the true data or not. So you can go for the activity view data. So you can get this and then view your own data. Or another way, you go for this icon, open activity window again. You can go for the tag. Tag means that you can create the descriptive statistics. So you click tag. You click which variables you want. For this example, I just want to know about all these variables. So I go up there, okay, here, and then click select all the variables. So let's say if you have your specific variables, you can go for the click one by one. So let's say here you don't want, so you unclick. So if let's say you want, okay, for this age only, so you click age only. Okay, so let's say for the shortcut, if let's say you want all this, so go up there and then click this one. So you get this. And then in this view, you can go for the fast tab, okay, and or you can go for the details tab. For this case, I choose details tab and the table, and then click OK. Okay, so now you get the descriptive statistic for the each variable. Okay, so the viewing, maybe you can go for the full or you can go for the brief. Okay, so let's say go for the full. So the for age, how many number for the age, how many missing you have. Okay, your mean age for the age. Okay, you have a skewness here. So all the descriptive statistics. Then go back to this activity window again, and then you can go for the graphical measurement. So let's say you go for the graph. The same, I want all these variables. Okay, so go up there, select, and then select variables. Or you can click one by one variables. And then you go for the generate chart. Okay, so you get this. So if let's say you want to manipulate or you want to edit this data, so you don't want bar, you can go for this dot only, or you can want the line, so you go for line only. So if you want to go to pie, so pie. So in this window, you can go for the editing data also. Okay, and then you can go back to the open activity window. Okay, so you go for the correlation. The main descriptive important for the predictive. Before you go for the build our model, you need to know the correlation for each variable. Means that from predictor versus our target. So you go correlation, click correlation. So let's say here you want all this correlate between each variable. So the same, you go for up there and then you select all. And then in this SPM, actually we have a lot of type correlation. So you can choosing depends on your preference. So basic one, the common we using is Pearson, but never mind if let's say you don't want Pearson, you have like Sperma, so you can go for this. Okay, you can choosing by this menu button. So let's say here we go for the Pearson, and then you click OK. Okay, so you get this result. Value R for correlation for each variable. So in this software, SPM software, they have a color coding. Let's say is white color here means that no correlation for each other. Okay, let's say dark color. Let's say for dark blue here, so means that higher positive correlation. So let's say that for the red color here means that your correlation is negative correlation. So or you want to do for the scaling vector, also you can go, or you want to choose it the correlation statistic. So means that you have minimum and the maximum. Okay, for this case, your target is Y is our target. Okay, so this one. And then the rest is our predictor. Okay. And then we go for the open activity windows. Okay, so you go for the model. Okay, in this model setup, okay, you need to the first, okay, easy for you, you can go for the sort by the file order of alphabet Z. Okay, so for this case I choose the file order, and then the target is target, and then the rest are predictor. So got that, and then predictor. But for this case, I think I don't want is post bin BR predictor, so unclick here. The rest is a predictor from the age until time employee. BR our predictor, and then based on our target, the target type is classification. Since we have a 0 and 1, 0 is no default, 1 is a default. So you go for this classification and regression binary. And then for your information, these all the analysis engine inside the SPM. But today, web demo, we just proceed with the basic one. Is we call it card decision tree. Okay, and then this one is the parameter you need to consider it. Okay, so for example, if let's say we go for the machine learning, so we need to go for the testing part, which is we dividing our data set. Be unlearned data set means that you want to build your model, and then the rest we are testing data set. You want to testing your model. So for this case, we go for the testing. Okay, whether you go for the fraction means that for example here is 0.2. So 0.2 means that 0.2 from the all the observation we are testing data. The rest are built data. Or you can go for the common technique we're using is cross-validation. So for this case, we go for the cross-validation. Or we go and then we choose the K equal to 10. Okay, the default one, the best high accuracy for the cut is starting with K equal to 10. Okay, for this case, we choose the K equal to 10. So choose cross-validation, K 4 or K equal to 10. Means that from our observation, we divide observation to 10 groups, and then first K, okay, we are testing, the rest K, we are the data, and then we go for the first iteration. Second iteration maybe K equal to 2, group 2 we are our testing, the rest we are the build data. So means that you can get the average for each iteration to checking our accuracy. Okay, so and then you go for the step. Okay, so now you get the card navigator. So I will do again. Go to main model setup. Okay, you need to identify your target. Okay, because our target is classification, so we choose classification. The rest be our predictor, exclude of the post bind, and then we go for the testing. We choose the cross validation. Okay, and then for the analysis engine, we choose the card decision tree and then click start. Okay, so you get this. We call it card navigator. You set your output here. This one is the card model. Okay, so basically card. What is card actually? So we go back to this one. Okay. CAT is a classification and regression tree. Okay. CAT basically is from the Brightman and Awesome in 1984. Okay. CAT is decision tree algorithm. Okay, that was by splitting a set of a yes row that splitting the response target variable into partition based on the predictor setting. So means that here in the CAT we have a terminal terminology you need to understand before you go further. The first one is we call it root node. This one is the node at the top, and then we have a splitting binary splitting, which is yes or no, or small or bigger. For this case, this one is we call it splitting, okay, variables. And then we have another term is we call it terminal node. Okay, in this terminal node, okay, we call it this one is terminal node because no have any sub branch. So that one is we call it that one is terminal node. Okay, inside each terminal node we have a predictive value. Okay, for this case, because this for this problem a classification, so our predictive value is probability. Okay, let's say for this case our predictive value is 85.7%. Okay, so basically a prediction is produced for each partition. So basically you can get prediction value from each terminal node. Okay, so remember again, in the card we have a lot of nodes. Inside node we have a terminal node. Inside terminal node we have a predictive value. Okay, so basically when to use CAT, CAT to identify the most important predictor of a response or target. Okay, from the CAT you can discover combination of predictor, or you can visualize your findings, or you can create the business rule that's easy to understand. Okay, so basically CAT is a relatively simple for non-statistician to interpreting. So I think I go directly to this software again. Okay, so this one is we call it CAT. For this case is the classification. Okay, so for this problem we have 10 terminal nodes. Okay, 10 terminal nodes. Okay, we have a 10 terminal nodes, and then our accuracy is 0.87. Okay, our ROC test. Okay, so it's quite high, and then we consider that one is can be the best model for this case. With the best model for this case is the CAT with the 10 terminal nodes. Okay, so for SPM, if let's say you want view, okay, you can view your node for each CAT. Okay, you can view for each CAT. So you go for the splitter. Okay, you go for the splitter. So you can get the splitting, okay, for each this terminal node. Okay, so this one is the same output from the n query. So you go for the accurate plan, or you want this view, so you can choose 3 details here. So it's more complicated from here. Okay, so let's say smaller, okay, bigger one. Okay, let's say for the first node here, n query less than 1.5, we have n query more than 1.5. Our predictor is 50%. Okay, and then we go from here to here. Okay, n query is let's say less than or equal to 4.5. Okay, we have a sub branch here is less than number of CAT less than 1.5. You get this predictive value. Okay, or you want to further is let's say number CAT more than 1.5. So you have another sub branch here. Okay, time employee less than or equal to 9 years. So you have another sub branch is income here, and then you get the predictive value here. Okay, so how CAT is works. Okay, from the roadmap, so we have split by our predictor itself. Okay, so means that for this case we have let's say this one is terminal 1. So we have a first row. So from here to here to here to here, you get this predictive value. Okay, so another way, we go here to here to here to here, and then to here you get a second terminal combination. Okay, so you have a combination of the rows inside the cat. Okay, so where you want to find the predictive value? In this terminal node, for each terminal node. So how they create the terminal node is from each combination. Okay, by this each splitting, so you get this predictive value. Okay. Okay, so from here, let's say for this case, we go for the optimum model, because this one is the less number of relative cost. Okay, so let's say you don't want this one is the best model, so you can go this toggle. Okay. So you click here, and then appear is a green color here. So green color means that one is the cut, other cut can be considered a good model. Okay, so let's say you go for the mean one SE. So let's say for here it mean one SE, the number of terminal node only 5, but the number of RC or the number of relative cost is higher than the optimum model. Okay, so let's say if like you get the first model for the optimum one, okay, with the less number of relative cost, okay, but the number of terminal node is the bigger, means that your model is complicated. So you need to find out less number of terminal node be a good model. Okay, this one is subjective, depends on your problem. Okay, so it's like say you go to the optimum value with the less number of relative cost, so you can go for this model. Okay, optimum one. So let's say you consider optimum one is not have a lot of number of nodes, so you can consider for mean one SE, the best model. Okay, so this one is how you can choose your model. Okay, and then from this model, okay, for the optimum model, so now we know about the rows, okay, for each terminal node here, and now we want to know about the what is the important predictor for this target. Our target is default. Okay, what is the most important predictor? So how you get this? So go for the summary. Okay, go to summary, go to variables important. Okay, so from this variables important, so we have n inquiries. We are the best predictor to the our target is or default or non-default. Okay, the second variable is number of cuts. Okay, and the third variable is have occupation list. Okay, and then the fourth one is age. They are the most important predictor. Okay, and then from here, from summary button, okay, also you can get the misclassification. If let's say you don't want to go for the RC, okay, so you can go for the misclassification to evaluate or validate your model. Okay, so for those a little bit with the misclassification, you go for the misclassification. For those proceed with the RC, so you can go for the RC to checking or validate your model. Is it okay or not? Okay, or you can go for the confusing matrices. Okay, so the actual part and then the total classes. This one is specificity and sensitivity in the confusion matrix. Also, this one is measurement to checking the accuracy of our model. Okay, or from each one, okay, from this also we want to know what the interest or important rows, because for this case, for this the best model here, the optimum model here, we consider that we have a 10 nodes. Okay, instead we have a 10 combination. Okay, but from the 10, which one is the interest one? Okay, the best combination to know or back to our objective is find out which customer go for the default status. So go here and then you choose one. Okay, so if let's say you go for this color coding, so if let's say the red color here is most, go for the default one. So for this case, we have a terminal node 2, terminal node 4, terminal node 8, and then terminal node 9. So from 10, we have most of the predicted third value is we have 4 terminal nodes. Okay, so to get this 4, okay, go for the hotspot, and then you choose focus class is 1, is a default status, and then click OK. Okay, so you go for the second bar chart. Okay, from here, okay, for the list, the higher one is a node 4. Okay, maybe you can looking what is combination of predictor for this node 4, or you can go for the class count. Okay, for the class count, the terminal node 9 is the higher number of the predictor based on the class count. So you can also go for the terminal node 9. Okay, so how to get the rows or combination for each one? So first one, we go for the terminal node 4, right click. So you go for the node report and then you choose rows. Okay, I will do. Go that terminal node 4, right click, node report, you choose rows. So from this combination is from the n equity less than 1.55 and accurate blank is more than 0.5. So this one is the from terminal node 4. Okay, the predictive, most of the predictive is default setting. And then also from the list and the class count, terminal node 9. So right click again, node report. Okay, so from here you get the rows. So rows for the terminal node is combination from the n increase more than 4.5 and then number of cards is less than 4.5. Okay, so you will get the rows for terminal node 9. Okay, so that's why. So for each terminal node, we have a different combination. Okay, so for this case, for predictive process using CAD model. So the first step, from the CAD, you can get the how many terminal nodes. From the terminal node, you can get the rows behind that one. Okay, so from there, you can go for the optimization. For let's say here, we have a terminal node 4. Okay, but it's combination, so you can go for the rows. So this one is the first combination, the important combination. They are default one. The second one is here. This one is the combination of the predictor. They are the default status. Okay. So as a banker, you need to consider that one is the most important combination. Or let's say you want to find out the most important predictor, so you go for the summary, find the variables important, and then you go for the variables important. So number of injury is the most important predictor. Okay. So after you get the best model here, okay, cut with the 10 terminal nodes, you can do the scoring or you can do the prediction if let's say you have a new data set. Okay, you can go for the prediction of scoring. So how to do? So is go to score, because now you consider that the one is the best model. Go to score. Okay. So you open the new data set you have. For example, I have the new data set. Okay, for this case, okay, new customer. Okay, new customer. Okay, we have a good unlabeled, so we open. Okay, so we go for the save it. This, okay, save it. I go for the scoring. Okay, score, and then save. Okay, so save all the model, save all the variables. Okay, and then choose the optimum one, or you can select to other three. So if let's say you don't want this one, so you can go for the which terminal node you consider that the best model. Okay, for this case is optimal, the other best one, and then you click score. Okay, now you get this one, so you go that data set. So I try open with the mini tab. Sorry, sorry, sorry. I go back to here again. Okay. So sorry, go back to score. Okay. Let's say you want save it already for the Excel. So you choose Excel. Okay. Sorry for this case. Okay. I go back to this scoring. Okay. Save it. Okay. Save. I choose easy for you. Go for the Excel file. And then I choose desktop. Okay. Click save. Okay, and save all the model, the optimal one, and then click score. Okay, score. So I go back to that one. So already in the Excel file, so you open this one. Okay, so now we have this variables. Okay, this one is ID, this one is response, the our predictive, the new predictive. Okay, so we just only have the predictor value. Okay, so now we have our response is the predictive value. Okay, so this one is probability for the no default. This one is probability of default. The response, the predictive value is the response. So from this software, from the SPM, after you get the best model, you can go for the scoring, or you can go for the predictive, or you want to translate to other language, this algorithm, so you go for the translate. Okay, so basically in SPM you can translate to other language like SAS, like C, like HTML or Java. Okay, so let's say you want to deploy this model. Okay, in this SPM also we have for those are familiar with the Minitab product, assistant menu button. For this case, for this SPM also we have a feature like that one, but we call it is automate. How to get it? So go back to this model setup. Okay, so go back to model setup and then automate. Okay, automate has the that kind of the features. Let's say here is, let's say, model. So what is a model? So let's say we choose the model here. So means that SPM we run all the engine, all the model in SPM, and then they decide for you what is the best model for this case. Okay, let's say this one is the features to help you to starting get the best model. Okay, and then for information also, you can customize. Let's say you can go for the post splitting. Okay, so you can create your own splitting for each variable here. Okay, for each predictor to get your own cut tree. Okay, So I think go back to this. Okay, so we cover for this all. Okay. 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 So basically, machine learning is one of the technique for predictive modeler, or for this case we are nature extension from the regression and binary logistics. Okay, actually it's useful to determine the key driver of any output. Instead, if let's say we go for the cut, we get the terminal node. So from the terminal node, you get the row behind that one. And then you can get also for the predictive value in that terminal node. Okay, so everyone can benefit from the having some knowledge around machine learning algorithm and terminology. Okay, so if let's say you want to try or buy this Salford Predictive Modeler, is one of the product by Minitab. Okay, to tackle for the machine learning. Okay, you can go for our website www.minitab.com or www.digits.com, or you can contact us or email us to sales@digits.com or minitab@digits.com. Okay, so if let's say have a Q&A session, so I'll open the Q&A session. Okay. Any questions? Any questions? So if let's say doesn't have any question, so I think I start here. So if let's say have any question, so you can email us to the sales. Okay, so the sales@digits.com or minitab@digits.com. Okay, so doesn't have. So thank you. See you again.